This is model RPK 120-60D. After taking off the outside cover, there's an inside cover, but there's a wiring compartment. And on the dimmable drivers using a wall box dimmer or control system, you'll see that 120 volt input is identified with black and white, and then this is a constant current driver, puts out DC, and it's identified with the red for positive, black is negative. Well, the drive current is 720 milliamps. Load is 42.2 volts. You can see those are the LEDs right there. So I'm just going to demonstrate how the dimmer impacts the dimming performance. Driver, just like a transformer, like a lot of things, if it receives voltage, it's going to be energized. So if I turn this off, right, power's out. So it's going to turn off. Turn it on, off. I know that sounds pretty simplistic, but what happens with certain wall box dimmers? Well, some wall box dimmers have a minimum load, and some of them work better than others. So this dimmer here, you'll see that it will slide, okay, and this is as low as this dimmer goes, and we're at 20 milliamps drive current. Okay, you'll see the LEDs are still on. Now why is that? That's because this dimmer, when it goes to the lowest dimming setting right here, does not shut off. So if I just measure the input to the driver, see, I'm still getting 27.4 volts. So I'm going to change this dimmer out with this dimmer here, a rotary style. Okay, so I swapped out this dimmer, same load, same driver, different dimmer, rotary style. So if I push it on, set it to full bright, drive current's 710 milliamps, load is 42.1 volts. So if I dim this, you'll see that it basically dims down. Until it drops off. It's off. Come back up, it will turn on up to full bright. So I'm rotating the knob. Okay. So that was a very, very slow turn. So if I just turn in a nice even turn, one full rotation, you'll see it goes right off. Okay, so now the driver is set to maximum load. You can see it has 59 volts of load. Drive current's 750 milliamps. Okay, so if we start dimming this, up to full bright, dim down. I also want to point out that electronics have minimum load requirements. And with that said, that includes drivers, which are electronic, and electronic may have in the center a magnetic coil to isolate the output, but still, if I just turn it, you'll see that there's quite a few electronic components in there. Now, Dimmers have some electronic components in them, obviously, and the same thing with them. They have minimum load requirements, and when they don't receive the correct load or the correct voltage, or something is a variable that's not accounted for, then it could change the expected performance. Okay, so you can see that this driver has a minimum load to operate, right? Typically the rule of thumb is 25% on our drivers. So this is a 60 volt driver. 25% of that is 15 volts. So I put a load of 16 volts on it, and you'll see that it's driving correctly. It's 700 milliamps. Now, if I dim it, we've got two things going on here. Number one, dimmers have minimum loads. So right now, it's okay, and as I start to dim it, you'll see it's dropping. Drive current's dropping, right? It's down to 300. But when you get down to the extreme minimums, that's at 100 milliamps. So it started at 700 milliamps. It's down to 100. As we drop it, you'll see that the LEDs may flicker. That's at 20 milliamps. So 20 milliamps down from 700 milliamps. Now, if I dim this in a faster capacity where it simulates a smooth dim drop, you'll see that it will burp and go off. But when you get down to, you have to have a certain load to have a smooth dimming range at the very, very bottom. Okay? Please send any emails, questions. Thank you.